In this problem, you're given that sine is 5 over 7 and cotangent is positive. Now, one very helpful thing to remember is that sine equals the y value over r. In order to do this, the rest of these, we have to figure out what is the x value. So, in order to do that, we would have 5 squared plus x squared equals 7 squared. Pause your video now so you can find out what x is. Solving for x, you see that it's the square root of 24. So now we're almost ready to fill in all of these trig values. But the first thing we need to do is figure out which quadrant this angle lies in. Remember, using the phrase forecast, that cosine is positive in 4, all are positive in quadrant 1, sine in quadrant 2, and tangent positive in quadrant 3. So in this case, we know that sine is positive because it's 5 over 7. We also know that cotangent, which also would imply that tangent, is positive. So we have both tangent and sine positive. In quadrants 2 and 3, it's just sine positive in 2 and just tangent positive in 3. So this means we must be in quadrant 1, where all of the values are positive. So now we just have to fill in our ratios, knowing that x is square root of 24, y is 5, and r is 7. So in this case, they already gave us sine, which is 5 over 7. Cosine is x square root of 24 over r, 7. Tangent is the y value of 5, the x value of the square root of 24. But we can never leave a square root in the denominator, so we have to multiply by square root of 24 over square root of 24, which will give us 5 root 24 over 24. Cosecant is the r over the y, which is 7 over 5. Secant is 7 over square root of 24, but we have to rationalize the denominator again, just like we did for tangent. So, in this case, we're left with 7 radical 24 over 24. And then here, we are just left with the x value, square root of 24, over the y value, 5. Today we'll be looking at trig ratios on the unit circle. And in case you forgot, the unit circle is a circle with a radius of 1. So essentially, the same rules apply as before, except for r, which really just stood for radius, the r value is 1. So instead of for sine y over r, it's just y, because it's like y over 1. Now for any point on the unit circle, it has a distinct x value and a y value. And since sine is y and cosine is x, you can think of the point as telling you what the cosine is for the x and then what the sine is for the y. And remember that tangent is the y over the x. This chart will be very helpful for figuring these out. And it's basically the reference angles of 30, 45, 60, and of course 90, 180, and 270, and 0 and 360. You may remember these values from the reference angles chart that we did before. Now I keep saying the word forecast to tell you which are positive, which are negative in each quadrant. So cosine is positive in quadrant 4 because you start in 4 and you go counterclockwise, and the first one is c, cosine. And as you can see, since cosine is the x value, look how all the x values here are positive. In quadrant 1, everything is positive because the x and the y are both positive. In quadrant 2, the x values are negative, but the y values, which correspond to sine, are positive. And in quadrant 3, tangent is positive because both are negative. And when you do a y divided by an x, you get a negative divided by a negative, which is a positive. To find cosecant, secant, and tangent, all you have to do is take the reciprocal of the corresponding value. So for example, if I wanted secant of 120 degrees, I would look at 120 degrees, and I know that secant equals 1 over cosine, or the reciprocal of cosine, which is 1 over the x value, or the reciprocal of this x value here. So secant of 120 is just negative 2 over 1, or negative 2. In some instances, they'll give you an angle greater than 360 degrees, like, for example, cosine of 420 degrees. What you have to do here is figure out what angle within 0 to 360 is 420 coterminal with. And all you would do is just subtract away 360s until you get to the right place. So if you subtract 360 from that, now that this is the same as cosine of 60, 60, cosine of 60 is the x value, 1/2. And if it were done in radians, you would just subtract 2 pi instead of 360, until you get an angle between 0 and 360. For these three problems below, we'll be using the unit circle chart on the right, and the fact of y for sine, x for cosine, and y over x for tangent. So, sine of 120 equals the y value at 120. If you look at 120 degrees, the point that corresponds is negative 1/2, comma, radical 3 over 2. Since sine, we're looking for the y value, sine of 120 degrees is simply radical 3 over 2. Secant is the reciprocal of cosine, or the reciprocal of the x value. So, at 7 pi over 4, the corresponding point is radical 2 over 2, comma, negative radical 2 over 2. So in this case, we're looking at the reciprocal of the x value, or we just flip this, so it's 2 over radical 2. As I've mentioned before, we can't leave a square root in the denominator, so you multiply by radical 2 over radical 2. You get 2 radical 2 over 2, but you can cancel out these 2's, and you're simply left with radical 2. In the last problem, tan of 15 pi over 6 is not on the circle, and that's because it's larger than one rotation around the circle. So, pause your video now and find the angle that's coterminal with 15 pi over 6. In order to figure out what that is, we need to subtract 2 pi from 15 pi over 6. Now, 2 pi can be rewritten with a common denominator of 6 as 12 pi over 6. So subtracting the numerators, we get 3 pi over 6, which simplifies to simply pi over 2 when you divide a 3 from both the top and the bottom. So now we know that tangent of 15 pi over 6 is equivalent to tangent of pi over 2. Pi over 2 is 90 degrees, or 0, 1. So for tangent, we use the y value, this point here is 0, 1, use the y value of 1 over the x value of 0, but since we can't divide by 0, tangent of 15 pi over 6 is undefined.